So it's important to understand this concept of electron microscopy for non-biologists. It's important to know that electron microscopy is two types: transmission electron microscopy and scanning electron microscopy. If we have a single sample of some powder which we have derived from some building material, so we take a sample, we take the powder off, or we take the dust sample and we have some powder form. That powder form can either be checked from TEM or SEM. In one, it will be put on a copper grid which will be put in a TEM machine, which you will see soon, and in SEM it will be put on a stub which will be seen under a scanning electron microscope. In TEM, what happens is the electron beam will pass through the sample, and that we will observe the shadow of the sample which we will get as an image. In SEM, the electron beam will fall on the sample and one detector is going to see the surface level morphology. So, this is the totality of TEM and SEM. We are going to see now the procedure. So, before we see any sample under SEM, we have to prepare the sample. To prepare the sample, we have to first have a stub. On this stub, we are going to put the sample, but before that we are going to use a carbon tape. This carbon tape is applied onto the stub and it is cut from the corners. And then from one side the black side is exposed. This is a carbon tape, and it's carbon because carbon is conductive. So as we gold coat something, we will make sure that when the gold coat comes to the carbon, the conduction is transferred from the stub to the machine, so that it creates a full circuit, and that's very important for this thing to happen properly without any charging effects. Then we take the sample. This sample has been properly dried, and after drying we take part of this sample . We put this on a film and then using a toothpick this is spread in a very thin layer. It is very essential to spread it as a thin layer, because only then can we see the particles properly. And at one point the thin layer should be even thinner, so that it can be seen properly. A very thin layer is made, and after this it is put into the gold splatter machine. Then we have to put it for splatter coating. This is the machine for splatter coating. Inside are the samples as are visible from here. The standard settings are applied. Once the work is over of sputter coating, the sample is taken out. This is actually in vacuum, but once it's complete, the sample is taken out and the sample looks something like this. This is a gold coated sample. The sample is kept in a desiccant system to keep it dry. Once you've kept it in the desiccant, then we take the sample for observation in the scanning electron microscope. A scanning electron microscope has multiple components. This is where the specimens are placed. This thing comes out when the vacuum is released. And over here you can see this is the knob where the rotating stage of the specimens can be changed. You can see here it's always in vacuum. So first the vacuum has to be pumped and then it has to be released. And when it's pumped in, it has to have a certain pressure so that only under that pressure the machine works properly. This machine also has place for a EDAX attachment, which lets us see the elemental composition, and you can see the workings. This is the screen where you can observe it in real time. Here is the keyboard and the control. You can see the various controls here. On the left side is magnification, on the right side is the focus. Then there are other controls like brightness and contrast, and then there are controls of the beam, and you can scan and rotate. This is the sample, powder sample, in which we have to investigate. This sample has been properly dried, and this dried sample has been suspended in alcohol, ethanol, till it is slightly turbid. It is important to keep it slightly turbid. After that, we want to make sure that the particles are equally dispersed, so we will sonicate the solution. To sonicate, this is the sonicator machine. In the sonicator machine, we are going to use a float and we are going to put our sample, which is suspended in alcohol. Now let us stain and prepare the sample for TEM viewing. This is the dispersed sample in alcohol. We take a fresh tip and then we take a drop of the sample, and on the parafilm you can see is a carbon coated copper grid with the carbon side on top. We are putting the sample and then we are leaving it for a few minutes for it to dry. Only when it is dried, then we have to take the PTA stain. The PTA stain is for the negative staining, and this PTA stain, a drop is taken of a prepared PTA stain, and this stain, a drop is put on the parafilm. Then in real time we will have to dry the copper grid properly, make sure it's not so wet, and then with a forceps you have to take the copper grid, which is carbon coated, and the carbon coated side for 10 to 20 seconds it's put on the PTA, and then this is put on the plotting paper, Wattman filter paper, and this is ready for viewing. Now here you can see this is the holder. This holder is taken out of a TEM, Transmission Electron Microscopy machine. Here the grid is placed inside. If it's a carbon coated grid, the carbon coated side is put on the below side. It's properly closed, properly first settled so that it's absolutely aligned, and then it's closed very delicately. This is then inserted into the electron microscopy machine. This one is a very high powered machine and it's not fully inserted. Then the cycle is on for vacuum. When the vacuum is closed, then it's fully inserted, and then we go for further viewing. You can see here are the control panels for the screen. You can see the alpha tilt, beta tilt. You can see this is for the beam, the trackball, the fine intensity, coarse intensity, exposure, You can see the magnification. You can see on the right is a joystick. You can see buttons for diffractions. And these are the two monitors. On the right side is the coarse adjustment which is made. And then on the left side, you can see at 5500 times. See, it's from the right side, it's transferred to the left side. And then we can view our sample. Apart from giving us the image at great magnifications, electron microscopy also lets us get insights into the composition of the materials, finding out more about the material. So the SEM, or the Scanning Electron Microscopy, gives us the energy dispersive X-ray spectroscopy, and the TEM also gives us the energy dispersive X-ray spectroscopy, but also gives us the selected area electron diffraction. Now what does this help us? The EDX, we will take a small part of the sample and we will get results as peaks. So we will be able to understand what are the elements that are present in a particular material or the particular compound or the particular sample that we are seeing. What happens in this is that the interatomic structure lattice, how it is arranged, can be seen. This can be compared against a standard and we can very conclusively see what is the composition of the material.